When it comes to the world's leading agricultural exporters, most people immediately think of the massive scale of the United States or Brazil. However, Spain, a country with a land area only about 1/20th that of the United States, is emerging as one of Europe's largest agricultural exporters, with export revenues exceeding $60 billion annually. But how can a water-scarce country, where average annual rainfall is less than half of the global average, compete directly with the world's largest agricultural economies? In this video, Agriculture Insight takes you deep inside Spain's agricultural powerhouse, where vast greenhouse complexes transform arid land into high-yield production zones, where pig populations outnumber humans and operate as an industrial system, and where integrated livestock and renewable energy models are redefining how land is utilized in an era of resource scarcity. At the start of this journey, consider a vast, white sea spanning nearly 370 square kilometers, over 30,000 hectares of plastic-covered greenhouses in southern Spain, often described as the only man-made structure on Earth visible to the naked eye from space. In Almería, the most arid semi-desert region in Spain, annual rainfall averages less than 200 millimeters, lower than in many parts of North Africa. Yet this extreme dryness has become a strategic advantage. The highest number of sunshine hours in Europe, low humidity, and consistently clear skies create ideal conditions for operating greenhouses with minimal need for heating energy. While global temperatures continue to rise, surface temperatures in Almería have, in some cases, shown a slight decline of around 0.3 degrees per decade. This phenomenon creates a stable microclimate for crops in the middle of a semi-desert, enabling year-round cultivation even under intense heat. Thanks to this optimized ecosystem, Almería alone produces more than 3 million tons of fruits and vegetables annually. Tomato output reaches approximately 1 million tons, with average yields exceeding 500 tons per hectare, dozens of times higher than open field farming. Meanwhile, bell pepper production stands at around 700,000 tons per year, positioning Spain as one of the leading suppliers of fresh produce in the European market. Instead of relying on chemical pesticides, the system is largely based on biological control. Over 60 to 70% of greenhouse areas in Almería use beneficial insects such as Aureus bugs and Encarsia parasitoid wasps to eliminate pests. As a result, pesticide residues are kept at extremely low levels, meeting stringent standards set by the FDA and major European retail chains. In addition, the secret behind this extraordinary productivity lies in a unique artificial soil system known as enharinado, a layered structure with clay at the bottom to retain water, organic matter in the middle, and a top layer of fine sand. This design helps conserve moisture, reduce evaporation, and distribute heat evenly to the roots. Combined with drip irrigation and soil moisture sensors, farms in this region can reduce water consumption by up to 80 to 90% compared to traditional agriculture, a critical factor in sustaining a billion-dollar agricultural system in the heart of a semi-desert. Leaving behind the greenhouse sea of Almería, we move to another agricultural icon of Spain, Valencia mandarins, the crop that has earned this region the reputation as Europe's citrus garden. Each year, Spain harvests around 2 million tons of mandarins, accounting for nearly 25% of global exports, surpassing the United States and many Mediterranean producers. In Valencia, where farmland is formed on mineral-rich alluvial soils from the Turia River and shaped by a typical Mediterranean climate of long, hot summers and mild winters, significant day-night temperature variation allows mandarins to accumulate high levels of sugars and essential oils. The result is vibrant color, intense aroma, and consistent sweetness, qualities that many growing regions in the United States or North Africa struggle to replicate uniformly at scale. From October through May, tens of thousands of seasonal workers arrive at farms across the Valencia region. harvesting is still carried out entirely by hand. Each fruit is carefully clipped close to the stem, using specialized scissors to avoid damaging the peel and to preserve the natural oil layer, an essential factor in maintaining quality during transport over thousands of kilometers to European retail chains. However, the Valencia mandarin industry is not without risks. The 2016-2017 season saw a significant drop in output due to prolonged drought and extreme heat waves. Even so, thanks to a widespread farming network and staggered mandarin varieties with harvest cycles extending up to 8 months, Spain has managed to maintain a level of supply stability that is rarely seen in the global fresh fruit industry. Few people realize that much of the olive oil labeled "Made in Italy" on global supermarket shelves actually originates from Spain, a country that accounts for over 45% of global production. With approximately 1.5 million tons annually, largely concentrated in Andalusia, home to around 340 million olive trees, the largest in the world. Starting in late October, olive groves enter a massive, highly mechanized harvesting season. In traditional olive orchards, where trees have thick trunks and wide canopies, the most common method is the trunk shaker. A hydraulic clamp attaches to the tree trunk and generates intense vibrations for several seconds, causing thousands of olives to fall simultaneously. To ensure no fruit is left behind, workers use mechanical poles in coordination to reach and clear the remaining olives on higher branches. On larger-scale farms, this technology is further enhanced with semicircular catch-frame systems that automatically expand to enclose the base of the tree, covering a diameter of up to 8 meters. When the shaker operates, all falling olives are collected directly into the frame, then conveyed via belts into storage bins attached to the tractor. This closed-loop process can achieve harvesting rates of up to 20 tons per hour, completely eliminating the need for manual ground collection and effectively transforming entire orchards into highly efficient, automated production lines. However, that level of productivity is still not the upper limit. In large-scale olive estates spanning thousands of hectares, where trees are pruned and planted in perfectly aligned rows like vineyards, Spain deploys a massive mechanical system, the high-clearance straddle harvester. This machine features a central processing chamber up to 4 meters tall, allowing it to fully enclose entire rows of mature olive trees aged 7 to 10 years. Within the system, high-frequency vibrating rods act directly on individual branches to detach the fruit, while dual-side conveyor belts immediately collect and transport the olives into onboard storage without allowing a single fruit to fall to the ground. Unlike trunk shakers, this system eliminates all manual intervention, transforming vast olive fields into continuous, uninterrupted production lines. With the capacity to process 20 to 30 hectares per day and harvest up to 60 tons of olives, this technology not only minimizes labor costs, but also ensures optimal fruit quality, as olives can be delivered directly to oil mills within the same day. Unlike traditional artisanal mills in Italy, modern olive processing facilities in Spain operate under an integrated industrial model, capable of handling up to 1,000 tons per day and running 24/7 during the harvest season. The process begins with cleaning and removing impurities, after which olives are crushed into a paste, slowly mixed in sealed tanks to allow oil droplets to coalesce, and then separated using industrial centrifugation. This entire process is completed within 4 to 8 hours after harvest to preserve polyphenol content, resulting in extra virgin olive oil with low acidity, distinctive flavor, and strong natural shelf life. Thanks to its stable quality, premium extra virgin olive oil can reach prices of 25 to 30 USD per liter on the global market, many times higher than other vegetable oils. However, a significant portion of this production is not sold under Spanish branding. Instead, Large volumes are exported to Italy, where they are blended, bottled, and re-exported under Made in Italy labels, capturing higher commercial value. If olive oil is considered the liquid gold of the Mediterranean, then in the Dehesa grasslands of southwestern Spain, more than 4 million Iberian black pigs form the foundation of Jamón Ibérico, one of the most expensive cured meats in the world. The origin of this distinctive flavor does not come from intensive enclosed farming systems like those in Iowa, but from the Dehesa ecosystem, a unique agroforestry landscape spanning millions of hectares across Spain. Here, sparse oak woodlands, shaped over centuries through a combination of grazing and forest management, create an ideal environment for free-range Iberian pigs raised at extremely low densities. Each animal has at least 2 hectares of land to forage and roam. Continuous movement across hilly terrain leads to slow but firm muscle development, while allowing fat to infiltrate deep into the muscle fibers, similar to the marbling found in Japanese Wagyu beef. The most critical phase occurs during the Montanera season, which lasts from October to March. During this period, a mature pig can consume up to 10 kilograms of acorns per day while traveling dozens of kilometers through the forest. Because acorns are rich in oleic acid, a beneficial fat also found in olive oil, the fat of Iberian pigs becomes exceptionally soft, with a low melting point even at room temperature, and develops a rich, nutty flavor reminiscent of chestnuts and dried herbs. However, raw material is only the beginning of a process that can take several years. After passing strict selection, the pork legs are buried in natural sea salt to remove excess moisture before entering the most critical stage, curing in naturally ventilated cellars for 36 to 48 months. Here, seasonal temperature variations of the Spanish highlands act as a biological catalyst, triggering complex enzymatic reactions that transform proteins and soft fat layers into hundreds of delicate flavor compounds. To ensure quality and traceability, Spain applies one of the strictest classification systems in the world through color-coded labels. The black label, known as Pata Negra, represents the highest grade, reserved exclusively for 100% purebred Iberian pigs that are fully free-range and fed only acorns during the Montanera season. The red label is assigned to crossbred Iberian pigs raised under the same acorn-based diet. Meanwhile, green and white labels are used for pigs fed on grain in modern farming systems. In the United States, a single black label Jamón Ibérico de Bellota can sell for between $4,000 and $4,500. However, its value lies not only in the curing time but also in the precision of its presentation. Master ham carvers, known as cortadores, use long, blade-like knives to slice the meat into nearly translucent pieces. Each slice achieves a perfect balance between deep red lean meat and fine streaks of white fat, designed to melt instantly on contact and release the full, distinctive, acorn-rich flavor. Leaving behind the oak forests of Iberian pigs, we move to the arid plateaus of Castilla-La Mancha and Castilla y León. Here, Spain maintains a massive sheep population of over 15 million, nearly 3 times that of the United States, and integrates them into the operation of some of Europe's largest renewable energy systems. The key distinction of Spain's sheep farming lies in its adoption of agrivoltaics, a symbiotic model combining agriculture and renewable energy. In semi-arid regions like Extremadura, where summer temperatures often exceed 40 degrees Celsius, instead of leaving the land beneath solar panels unused, sheep are allowed to graze directly under elevated solar arrays. This system creates a highly efficient economic loop. While solar panels provide shade that reduces ground temperatures by 3 to 5 degrees Celsius and helps retain soil moisture, allowing grass to grow even during extreme heat, the sheep, in turn, act as biological lawn mowers. They naturally clear vegetation around the solar structures, reducing fire risks and saving millions of euros annually in mechanical maintenance costs. Beyond optimizing land use, management processes are fully digitized. Through electronic identification systems, each sheep has an individual profile that tracks everything from nutrition to milk and meat productivity. Vaccination and health monitoring are automated on scheduled programs. Notably, the milking process operates on modern rotary systems, where automated units read electronic chips to adjust milking frequency for each animal individually, ensuring maximum hygiene and preserving the freshness and quality of nutrients. With over €2 billion in annual exports, this model not only helps Spain maintain its leading position in global sheep meat and cheese production, but also represents a new approach, transforming some of the harshest landscapes into a decisive competitive advantage in an era of water scarcity and climate change. In the world of tropical fruits, orange juice stands at the pinnacle of industrialization, thanks to its unparalleled capacity for concentration and flavor standardization. Yet few realize that behind this seemingly ordinary glass lies a dramatic shift in power, as Florida gradually relinquished its historic dominance to Brazil, a country that now controls nearly 70% of the global industrial orange juice market. The key lies in São Paulo state, where iron-rich basaltic soil, combined with almost military-grade production discipline, has transformed fresh oranges into a form of liquid gold, governed by some of the strictest standards in the world. From July through February, São Paulo enters a massive harvest campaign, yielding over 12 million tons of oranges. Despite the scale of industrial operations, harvesting is still carried out entirely by hand under uncompromising rules. Oranges are never allowed to touch the ground. A single contact with grass or soil is enough for immediate rejection, eliminating any risk of bacterial or yeast contamination from the earth. Instead of pulling or tearing, workers use a precise wrist-twisting technique to keep the stem and outer peel completely intact. This is a strategic requirement, because even the smallest scratch that releases peel oil can introduce bitterness and compromise the purity of the juice. Everything moves at extreme speed. Oranges must reach the presses within 4 hours, the critical window to lock in vitamin C before oxidation begins to interfere with the fruit's original flavor profile. Inside the plant, the production cycle accelerates as gondola trailer trucks arrive one after another. Each trailer carries up to 120,000 oranges, feeding the massive extraction lines that lie ahead. Unloading takes place on hydraulic tipping platforms, where entire trailers are tilted at 25 degrees or raised nearly vertical to harness gravity. Within seconds, hundreds of thousands of oranges cascade onto conveyor belts, marking the official starting point of the processing journey behind the world's most widely consumed juice. From the intake basin, the oranges move through pre-washed tanks, where they are sprayed with a food-grade alkaline solution combined with high-pressure water. At the same time, a series of continuously rotating brushes scrub the peel surface, stripping away dirt and environmental microorganisms. This is a critical control step in industrial processing. The peel must reach near absolute cleanliness before entering the extraction machines, preventing any risk of cross-contamination that could alter the flavor integrity of the juice. After washing, the oranges enter the grading stage to optimize extraction efficiency. First comes mechanical screening, where the fruit rolls across parallel cylindrical bars with progressively wider gaps, rotating to inspect the surface, while gravity allows each orange to drop into the correct chute according to its diameter. Operating at a throughput of 2,000 to 3,000 oranges per minute, the line maintains a steady and continuous flow of raw material. Next is manual sorting, where workers serve as the final quality control layer, removing damaged or defective fruit. At this point, the line is strategically split. Oranges with flawless appearance are directed to the fresh fruit market, while the juiciest fruit is sent straight into the extraction system, the operational core of the plant. Here, the most critical stage of the process begins. Oranges are fed into extractors, operating at up to 800 fruits per minute. Depending on the technology, the machines use either rotating conical reamers or decisive metal prong systems to separate juice and pulp from the peel in a single motion. The hollowed peels are then crushed and repurposed as livestock feed, while the orange pulp is collected in heavy-duty plastic liners and stored inside sealed metal tanks to prevent oxidation. After thermal processing, the orange juice is pumped into specialized refrigerated storage tanks with capacities of up to 1 million gallons. Within a sterile, tightly temperature-controlled environment, the juice can preserve its vitamin content intact for up to 2 years, without the need for any preservatives. At the final stage, the juice is filled into plastic bottles that have been thoroughly sterilized. To completely prevent recontamination, hot filling is carried out at a controlled temperature of approximately 80 degrees Celsius, eliminating any remaining microorganisms inside the packaging. Once sealed, each bottle passes through a high-speed camera inspection system, capable of detecting even the smallest defects, such as misaligned caps or microleaks, to ensure absolute airtight integrity. Finally, the standardized juice batches are labeled, palletized, and transported in refrigerated trucks to destinations around the world. From here, orange juice moves beyond supermarket shelves to become a core ingredient across multiple industries, from food products like dairy and confectionery to cosmetics manufacturing and the extraction of vitamin C for global nutritional and pharmaceutical supplements. In Poland, massive apple production is both an advantage and a burden. Prolonged oversupply has meant that in many seasons, apples are left to fall and rot in orchards because harvesting costs exceed market prices. Yet this very paradox has opened an alternative path. Nearly 2/3 of Poland's apple output is sent directly into industrial processing lines, allowing the country to capitalize on low-cost raw material and rise to control around 25% of the global apple juice concentrate market. From September through November, the harvest unfolds at an intense pace under strict requirements, designed to preserve maximum commercial value. Workers do not pull or tear apples from the branch. Instead, they use a lift and twist technique. This method keeps the stem intact and preserves the apple's natural wax layer, a biological shield that protects the skin from environmental stress. A skilled worker can harvest up to 200 kilograms of apples per hour, filling dozens of specialized fabric-lined picking bags without leaving a single bruise on the fruit's flesh. As labor costs in Europe have risen by more than 25% in just a few years, fleets of AI-powered drones have been deployed across Poland's apple orchards as a profit optimization solution for the juice industry. Equipped with AI systems, LiDAR sensors, and multispectral cameras, the technology can scan entire tree canopies within seconds, accurately analyzing each fruit's size and pigment accumulation without making physical contact. Once a target is identified, a vacuum-assisted robotic arm gently harvests the apple with controlled suction, reducing bruising rates to nearly zero. A significant advancement over traditional mechanical shaking methods that often cause severe tissue damage. Each system can operate 24/7, achieving productivity of up to 1 ton per hour, enabling growers to seize the optimal harvest window, precisely when apples reach their ideal sugar levels. The journey begins with a comprehensive purification process as soon as the apples arrive at the facility. They are immediately directed into a recirculating water tank system with continuous aeration. Here, the combination of dynamic water flow and a safely diluted chlorine solution works to remove soil, dust, and residual crop protection chemicals from the surface. The apples then move on to a roller conveyor equipped with high-pressure spray nozzles to complete the cleaning stage, ensuring that each fruit reaches maximum surface purity before advancing deeper into the processing line. Washing alone is not enough. The apples must be dried immediately to prevent microbial growth. A system of high-capacity air blowers, working in coordination with soft brushes, eliminates all surface moisture. At this stage, a direct inspection team carefully monitors the line, removing any bruised or physically defective fruit, ensuring that only the healthiest raw materials proceed further. Immediately afterward, the grading process moves into a more advanced technological tier. Through a network of high-resolution cameras and sensors, the system automatically analyzes color, size, and even internal defects that are invisible to the naked eye. Based on this real-time data, a pneumatic sorting system directs the flow. Fruit that fails to meet visual standards is diverted to the juice extraction line, while flawless apples are packaged for the fresh export market. Once grading is complete, the apples reach a structural turning point. They are fed into a high-capacity crushing machine equipped with high-speed rotating blades. Under intense rotational force, hundreds of tons of apples per day are rapidly reduced into a mixture of pulp, juice, and peel. The result is a uniform apple mash, the critical raw material for the subsequent juice extraction stage. The crushed mixture is immediately transferred to a modern belt press system to recover the valuable juice. Thanks to its continuous operation and high efficiency, this method preserves the apple's natural flavor. The dry pomace is not wasted, but repurposed as livestock feed or raw material for the pharmaceutical and cosmetics industries, maximizing the overall value chain. The extracted juice is then filtered to remove residual solids and impurities, before being sent to heated agitation tanks, maintained at 35 to 45 degrees Celsius, to stabilize enzymes and break down pectin bonds for optimal clarity. Once the desired clarity is achieved, the juice undergoes rapid cooling to lock in flavor, followed by tubular pasteurization with instant heating and cooling, eliminating microorganisms while preserving the fruit's essential qualities. While the juice is being prepared, a parallel cleaning system sterilizes the empty bottles using sterile water or high-pressure air at 80 degrees Celsius, eliminating any potential microbial contaminants. Finally, the automated line performs filling with absolute precision in a sterile environment. The caps are immediately sealed to create a perfectly airtight space, followed by labeling with full traceability codes, ready for distribution to consumers. The Netherlands and Spain are the two true superpowers of greenhouse cucumber exports, supplying Europe with fresh cucumbers all year round. Meanwhile, Russia, Japan, and China operate vast greenhouse complexes that produce millions of tons annually, meeting massive domestic demand while also serving export markets. Compared to traditional open-field farming, greenhouse cucumbers stand out for their ability to be grown under precise control of temperature, humidity, and nutrients, resulting in uniform growth, perfectly straight, glossy green fruits with a crisp, refreshing taste. On the same land area, greenhouse cultivation can yield 6 to 10 times more cucumbers than traditional methods, thanks to vertical growing systems that maximize space and harness every ray of light. However, this comes at a price. Greenhouse cucumbers typically cost 2 to 3 times more than outdoor-grown ones, due to the heavy investment in infrastructure, technology, and energy. Every year, greenhouse cucumbers reach a staggering output of around 40 million tons, nearly half of the world's total supply, bringing in an estimated 27 billion USD for the high-tech agriculture industry. With their unmatched productivity and consistent quality, greenhouses are seen as the farming method of the future, paving the way for sustainable agriculture worldwide. Now, step with me inside these lush greenhouses, where miracles are crafted by diligent hands and the technology of tomorrow. To achieve a high survival rate and ensure uniform fruit quality, 90% of cucumber farms today choose to cultivate from seedlings germinated in modern nurseries. The first step in seedling production is preparing the substrate trays. These trays are typically 50 by 30 centimeters in size and divided into 40 to 60 evenly spaced cells. Inside each cell lies a layer of substrate made from coconut fiber, peat moss, or rock wool, materials that are lightweight, airy, and disease-free. On the tray surface, an automatic perforation system creates small holes about 1 to 2 centimeters deep, allowing the seeds to settle neatly. Alongside tray preparation, cucumber seeds are also carefully processed and meticulously selected. These seeds are taken from specially chosen cucumbers with high uniformity, firm shells, and completely free from pests, diseases, or cracks. In the sowing process, a vacuum system lifts each tiny seed, evenly distributes them along the conveyor, and drops them precisely into the pre-made holes in the substrate trays. Next, the conveyor carries the trays through a sprinkler system that simulates artificial rain. The water is applied in a fine, even layer, just enough to moisten the surface coating without causing waterlogging. This step is crucial to ensure a high germination rate. Finally, small sticks about 20 to 25 centimeters long are placed into each cell to guide the seedling's growth, helping them develop upright. The trays are then gathered and transferred to the nursery area for the next stage of care. In many high-tech farms, instead of direct seeding, cucumbers are cultivated from pre-nurtured seedlings. These healthy young plants, about 10 to 15 centimeters tall, are transferred into greenhouses using automated transplanting systems. This method increases survival rates, ensures uniform growth, saves time, and significantly shortens the production cycle. In modern nurseries, seedling trays are placed under strictly controlled environmental conditions to maximize survival rates. Temperatures are kept stable at 25 to 28 degrees Celsius, while humidity is maintained between 80 to 90% to create the perfect environment for germination and early growth. On cloudy days, specialized LED lights are switched on to provide supplemental photosynthetic illumination, ensuring seedlings maintain a steady growth rate. At the same time, irrigation and nutrient delivery systems are fully automated, supplying dissolved fertilizer solutions tailored to each growth stage. Thanks to desynchronized care, after just 3 to 4 weeks, the young plants reach heights of 15 to 20 centimeters, bearing 2 to 3 deep green true leaves, with evenly spread roots and sturdy stems supported by the guiding sticks placed earlier. Once they meet the required standards, all trays undergo a final inspection, where weak or uneven seedlings are removed. Afterward, the seedling trays are neatly packed, carefully arranged on conveyor lines, and moved into temporary storage. Here, humidity and temperature are kept stable to prevent transplant shock during transport. Finally, the trays are distributed to commercial greenhouses, ready to begin large-scale cultivation. Inside the greenhouse, healthy seedlings are carefully prepared by workers before being transplanted. Each young plant is gently placed into substrate bags or specialized growing racks, where planting holes have already been prepared. Immediately afterward, a drip irrigation system is connected directly to the base of each plant, ensuring precise delivery of water and nutrient solution. Cucumbers are not simply watered in the usual way, but nourished through a hydroponic drip system with a precise formula of nitrogen, potassium, magnesium, and other micronutrients, often referred to as a nutritional cocktail. Thanks to this laboratory-like precision, the plants can grow so rapidly that they may stretch several centimeters overnight, leading Dutch farmers to joke that they can actually hear cucumbers growing. Because cucumbers grow so quickly, workers must frequently use tools to secure the growing tips, preventing the plants from spreading out of control. Overhead, trellis systems are installed along each row, with the stems clipped to the wires using small plastic fasteners to guide them upright. As the vines lengthen, they are carefully wrapped around the wires or lowered, creating infinite plants that can reach 10 to 12 meters and continue producing fruit without pause. Thanks to this technique, the cucumber rows stand neatly aligned like a vibrant green wall, maximizing light exposure and ventilation, and yielding straight, uniform, high-quality fruits. During the growth phase, cucumber greenhouses are monitored by advanced sensor systems that continuously track temperature, humidity, and CO2 levels. In daylight hours, additional CO2 is supplied to boost photosynthesis, which can raise yields by 20 to 30%. Yet even a 2 to 3 Celsius fluctuation or a shortfall of water can make the fruit bitter, so shades, fans, and misting systems are constantly adjusted automatically. Throughout the care process, workers regularly remove old leaves, diseased foliage, and unnecessary side shoots. This pruning improves light penetration and airflow, reducing the risk of fungal diseases. At the same time, nutrients are directed toward flowers and fruits, helping cucumbers grow straight, uniform, and of the highest quality. Cucumbers in greenhouses are vulnerable to pests, from aphids and thrips to spider mites. Instead of using chemical pesticides, farmers release beneficial insects, natural predators that hunt down these pests. At first glance, these tiny particles may look like pesticides, but in fact, they are living insects, tiny guardians released to protect the cucumbers. While cucumbers grown in open fields require bees and other insects for pollination to bear fruit, this is almost impossible inside greenhouses. For that reason, most greenhouse cucumber varieties are parthenocarpic, able to set fruit without pollination. Thanks to this trait, the plants produce reliably even in closed environments. Moreover, the cucumbers remain straight and smooth, free from curves or deformities. Thanks to the combination of smart monitoring technology and meticulous care, after about 30 to 40 days of planting, each cucumber vine in the greenhouse reaches peak performance, flowering simultaneously and entering a phase of steady harvest. At this stage, workers pick cucumbers every 2 to 3 days to ensure the fruits reach standard size, retain their crispness, and keep a deep green color. To guarantee premium quality, harvesting is done mostly by hand. Skilled workers walk along each row, using small knives or specialized scissors to gently cut the stems, then carefully place the fruits into crates or carts to avoid scratches. Once the carts are filled, the results of weeks of careful cultivation are immediately transported to processing facilities for sorting and packaging, where each cucumber is meticulously prepared before reaching consumers worldwide. But have you ever wondered what happens to cucumber plants once a harvest is completed? Cucumbers are short-cycle crops, producing for only a limited period before quickly declining. For this reason, once the final fruits are picked, the entire vines are cut down, collected, and sent for composting or recycled into organic fertilizer. This not only cleans and resets the greenhouse for the next planting cycle, but also helps close the loop of sustainable farming. Meanwhile, at the packing facility, freshly harvested cucumbers are placed onto an automated conveyor system and directed to different packaging zones. Here, each cucumber undergoes a visual inspection, with misshapen or scratched fruits removed, before passing through grading machines that sort them by size and weight into uniform groups. What sets greenhouse cucumbers apart from those grown outdoors is that they do not need to be washed before packaging. Because the entire growing process is strictly controlled, the plants never come into contact with soil, rainwater, or chemical pesticides. Even the workers responsible for plant care or harvesting must undergo strict disinfection procedures before entering the greenhouse. As a result, the cucumbers retain their natural waxy coating, a protective layer that preserves freshness and crispness throughout storage and transport. The selected cucumbers are then directed to be tray-packed, shrink-wrapped, or neatly placed in cartons, ready for labeling and shipping. Finally, once labeled, the boxes of cucumbers are neatly lined up on conveyors. Robotic arms automatically lift and stack them onto pallets, forming sturdy blocks of goods. Every pallet is standardized for easy transport and cold storage. From here, the cucumbers are ready to leave the facility, heading to supermarkets and dining tables around the world. If there were a global strawberry showdown, China would be crushing it in volume. But the United States, it's leading in prestige. In China, over 3 million tons of strawberries are harvested every year, nearly 3 times more than the US. An impressive number, no doubt. But if you ask the world which strawberry jam brands they actually remember, the answer lies across the Pacific. Smucker's, Bon Maman, Welch's, and a lineup of legendary names all hail from America. Because in the US, strawberry jam isn't just a breakfast spread. It's a culture, an industry, and the global gold standard of sweet perfection. The US may not grow the most, but it knows how to turn a humble berry into something the world loves to spread on toast every morning. The reality is, not every strawberry makes it to consumers while still fresh. Left too long, it spoils quickly, and that's exactly why the processing industry exists. Turning strawberries into jam isn't just about preservation, it's a way to extend the life of a delicate fruit, reduce waste, optimize the supply chain, and transform something fragile into lasting value. At high-end strawberry farms, where every berry is selected for export or premium jam production, automated harvesting machines are becoming the go-to solution. Equipped with AI-powered cameras and soft robotic arms, these machines can accurately identify ripe strawberries and gently pluck them using silicone grippers or vacuum suction without damaging the fruit or tearing the stem. The entire process is smooth and precise. Each berry is placed into soft, cushioned trays immediately after picking to preserve its shape and freshness. A single machine can harvest up to 10,000 pounds of strawberries per day, operating mainly in the early morning hours, the golden window to lock in flavor and quality. Even as technology reaches into every furrow of the field, in the United States, strawberry harvesting, especially on organic farms, hilly terrain, or hard-to-reach areas, still belongs to the hands of human workers. Strawberry pickers move like silent artisans, carefully weaving through the rows, selecting the perfect berries at just the right moment. Each fruit is gently placed into ventilated plastic trays, lying in a single layer like eggs in a nest. No stacking, no crushing, no bruising. Once a tray is full, they make their way quickly back to the collection point to transfer the berries into cold storage. This must happen within 1 to 2 hours of picking. Any delay and the quality starts to slip away. On average, each picker harvests between 9 to 13 kilograms of strawberries per hour. It may not sound like much, but this work supports over 55,000 seasonal jobs across the U.S. each year, most of them held by immigrant agricultural workers. Hand-picking doesn't just preserve the quality of each berry, it sustains the livelihoods of tens of thousands of families. That's why the American strawberry industry is not only efficient, but deeply human at its core. After harvesting, strawberries are quickly transported to nearby pre-processing facilities, usually located close to the farms, where sorting begins while the fruit is still at peak freshness. This step plays a critical role in determining the destiny of each berry. Some will be selected for fresh sale at supermarkets or local markets, while the rest will enter processing lines to become jam, frozen fruit, or dried products. Only the highest quality berries, bright red, plump, unbruised, and free of pest damage, are kept, while those that are soft, scratched, or uneven in color are removed immediately. Sorting requires not only a keen eye, but also speed and experience, as strawberries begin to lose freshness rapidly, just a few hours after being picked. On large farms, harvesting may take several days, and sorting can continue non-stop from morning until night. Careful sorting ensures not only product quality but also efficiency in the next stages of production. Each selected strawberry must be evenly ripe to guarantee consistent color, texture, and overall product quality. After careful sorting, the selected strawberries are gently packed into specialized boxes or cartons with soft padding and ventilation holes to protect the fruit throughout transport. These boxes are then sent directly to cold storage facilities, where stable, low temperatures help preserve their freshness and quality. From there, part of the strawberries is distributed to local supermarkets to meet domestic demand, while higher-grade batches continue their journey toward export markets, appearing on breakfast tables across the United States, Europe, and Asia. But what about the strawberries that don't make it to the fresh market? They're given a second, sweeter destiny, heading straight to jam factories. As soon as they enter the line, strawberries are preliminarily sorted and neatly placed into individual molds, ready for stem removal. More than 2,000 berries per minute glide through an automated blade system, where each stem is sliced cleanly with near-perfect precision. A deviation of just a few millimeters can cause the blade to cut into the soft flesh, distorting the berry's shape, and in this industry, even the slightest imperfection can instantly cut its commercial value in half. Strawberries are then placed on rotating rollers and pass beneath a series of high-pressure water jets. These jets are carefully calibrated to remove dust and surface residue without bruising the delicate fruit. Immediately afterward, the berries slide into a high-capacity washing tank, where powerful water agitation dislodges any remaining sand, stems, or leaf fragments. Throughout this process, a network of guide rails ensures the berries remain evenly spaced and cushioned, reducing physical impact and preserving the fruit's integrity during continuous cleaning. This multi-stage wash is critical for meeting food safety standards while maintaining the berry's appearance and texture. After cleaning, the strawberries move onto an inspection belt, where trained workers manually sort through each batch. Damaged, overripe, or discolored berries are quickly removed to ensure only high-quality fruit continues down the line. This hands-on step adds an extra layer of quality control that machines alone can't guarantee. Now, let's take a closer look at a process we rarely get to see, but one that plays a crucial role in preserving the full flavor and value of every single strawberry: freeze drying. The process begins with an ultra-fast deep freeze, plunging the strawberries to around -40 degrees Celsius. The frozen strawberries enter a vacuum drying chamber. Through a process called sublimation, the ice within the fruit evaporates directly into vapor. A powerful upward airflow lifts the berry pieces slightly, causing them to bounce and hover just enough to stay separated. What makes freeze drying stand out isn't just the technology, but the results. Unlike conventional drying methods, which can strip away up to 40 to 50% of the fruit's vitamin C, Freeze-drying retains more than 95%. The strawberries emerge light, crisp, and intensely flavorful, packed with their original sweetness, natural aroma, and essential nutrients almost completely intact. After passing through the freezing tunnel, the strawberries move on to manual inspection, where workers carefully sort through each frozen piece, removing any that are bruised, freezer burned, or don't meet quality standards.